Hello everyone and welcome to Pepcoding. I hope you all are extremely good. So today in this video we are going to discuss the first question of graph module, that is the number of distinct island, right? So in this question we are given a m cross n binary matrix. Now binary means that only zeros and ones are present in that matrix, and we have to return the number of distinct islands, right? So we have to write this function and return the number of distinct islands present in the binary matrix, right? Now we have done this type of question in level 1 also, in which we have to find the number of islands present in our binary matrix, but in this question we have to find the number of distinct islands, right? So here it is given that an island is considered to be the same as another if and only if one island can be translated to equal the other without rotated or reflected, right? So we have to find out how the two islands are same or different. So let's discuss this with the help of an example. Let's suppose this is the matrix, binary matrix. If consider all these zeros as the water, right? All these zeros are water, and suppose that these ones are representing the land. Now an island is what? A piece of land around which the water is present. So this is our island, this is our island, and this is an island, right? So in this matrix three islands are present. If we have done this, we have done this type of question in which this matrix is given and we return 3 as our answer, that is the number of islands present in our matrix. But in this question we have to return the number of distinct islands. Now distinct means different. Now the islands are different in structure, right? If the islands are different in structure, then these are different, right? Now the structure of this island is like this, the structure of this island is like this, structure of this island is like this, right? So the structure of these two islands are same, right? So these two islands are same, but these two islands are distinct, right? These two are distinct, these two are distinct, but these two are same. So the actual answer for this question should be 2, that is number of distinct islands present in this matrix is 2, that is this or this and this or this and this, right? So these are distinct but these are similar, right? So distinct islands are 2 only, right? So we have to return 2 for this matrix. So how we are going to do this? So we have done this type of question. So in that question we are using what? DFS. In this also we are going to use DFS, right? So we are going to apply DFS on all the ones present in the matrix, right? So we have to traverse the entire matrix. We are starting from 1, right? So call DFS on 1. So in order to find that whether the two islands are same or different, we are going to use a string in which we are going to add the path of the island, right? So when we are calling DFS on any of the one, we will add a x to our string, right? So we call DFS on this one, we add x to our string, right? After calling, this will move in all the 4 directions, here, 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 that is top, left, down and right. Firstly one move in the top direction, this is invalid. Left direction, left move is also invalid. Then one will move down, so we will call DFS on this one now, right? So this one will also move in the 4 direction, that is top. Now when this one will move in the top direction, it will again go to this one will again call DFS, it will again go here. So an infinite calls will take place. So in order to avoid this, what we are going to do, when we call DFS on this one, mark this one as 0. This means that this one is visited now, because we are not visiting the zeros, right? So this one is visited now. Now check the 4 direction. Firstly move in the top, left, down. So this will move here, call DFS on this one. Since we are moving in the down direction, so add a character which indicates that we are moving in the down direction in our string, right? So mark this also to 0. because this is visited now. Now move in the 4 directions. Top we can't move because 0 is present. Left is an invalid move. Down is 0 is present. In the right also 0 is present. So since this one complete all its call, all the 4 calls, so it will backtrack, right? Now this one will move in the right direction. Since we are moving in the right direction, so add a character which indicates that we are moving in the right. So it will move in the right. This one is also marked to 0, which indicates that this is visited now, right? This will also move in the 4 direction. Top invalid, left 0 is present, down 0 is present, right 0 is present. So this one complete all the 4 calls, it will backtrack. This one also complete all the 4 calls, it will backtrack. Now this is the path. This string indicates the path of this island, right? The structure of this island, you can say the structure of this island, right? So since we want distinct structure, right, now we know that in order to find the distinct elements, we can use sets, right? So add this path to the set. Now this set indicates that we have traveled one of the island in our matrix, right? Which is one distinct island in our matrix, right? Now this will, we can't convert this one again to 0 again to 1 because this whole island is visited now, right? So next, these all are 0, so we'll move here. So when we are traversing a island, we always start from the top left corner, here also, right? So this will help us in getting the correct structure of the island, right? So we are always starting from the top left corner of the island, right? So here is a one to take a new string. In each call, when one DFS is called on any of the one of the matrix, we are creating a new string, right? So since we are calling DFS on this one, so add a x to our string. Now this one is visited now. Move in all the 4 directions. Top 0, left 0, down. Since we are moving in the down direction, add a d here, right? So this is marked. Now move in all the 4 directions. All the 4 directions are visited, right? So it will backtrack, right? Next, this one will move in the right direction, right? Now DFS is called on this one. Since we are moving in the right direction, so add a r to the string. Now mark this to visited. All the 4 directions are visited, so it will backtrack. This one also completed its work, so it will also backtrack, right? So now the path of this matrix and the path of the previous island, the path is of this island and the path of previous island is exactly same, which means that these two islands are same, right? But we want distinct islands, right? So in the set only unique elements are present, so this will not add in the set twice, right? It will add only one time, right? So it is already there, so it will not add, will move it at the next island. So here we again find a 1, so take a new string. For each call we are taking a new string, right? So string, since we are calling a DFS on 1, so add x to the string. It is marked, it will move in all the 4 directions since only zeros are present here, so add this string to our set, right? Now we have traversed the entire matrix, right? So in this set we are getting two answers, which means that two distinct islands are present in this matrix, right? Which is correct because these two islands are same, so only two distinct islands are present in this matrix. Three islands are present, but distinct islands are two, right? So this set plus DFS, that is hashing plus DFS, will help us to find the number of distinct elements in our matrix. Now there is a problem in this approach. Not approach, but we have to do something more, right? So let's suppose ones are present here and ones are present here. Here let's suppose 0 is present, right? So ones are present here, right? Now these zeros are indicating water, right? So we can see that the structure of this island and the structure of this island is different, right? Structure of this island is like this, the structure of this island is like this. So these two are different. This means that this should be the number of distinct islands in this matrix should be 2, right? But if we are using this, right, so we call DFS on this. We are taking a string, add x to that string. Top we can't move, mark this to 0. In top can't move, in left we can't move, in down we can move, right? So add a d to the string, move to this, right? Next, mark this to visited. Now we can't move in any of the 4 directions, right? So we'll backtrack from this, right? Next we are moving in the right direction, so add r to the string, right? Now mark this to visited. Now we can't move in any of the 4 directions, so backtrack from this. Now this one complete its work, so backtrack from this also, right? So, right, so we have visited this island, right? And this is the path representing this island. So add this path to our hash set, to our set, right? Why we are taking set? In order to get the unique islands, right? Distinct islands, right? Next we are moved here, the top left corner of this island, right? Again we are taking a new string. We are taking a new string, call DFS to this one, add x to this string, right? Now this one is marked to 0 because this is visited. Now move in all the 4 directions. In top we can't move, left we can't move, in down we can move, right? So add a d to the string, move in the down direction. Now mark this to 0. Now here also we can move in the 4 directions. Top can't move, in left we can't move, in right move, in down we can't move, in the right direction we are moving, we can move, right? So move in the right direction, call DFS on this one. Since we are moving in the right direction, so add r to the string, mark this one to 0. And now we can't move in any of the 4 directions. Simply backtrack from this, and backtrack from this one, right? So the path of this island is what? XTR. The path of previous island is what? XTR. So we are getting the same path, so it is going to return us 1, but the structure of these two islands are different, right? The structure of this is like this and structure of this is this. These two are distinct, but this approach is giving us the wrong answer, right? So how we can avoid this? There's only one thing that we have to add. Suppose we are here, call DFS on this one. We have to add x to our string, right? When we are calling DFS on any of the one, we have to add x to our string, right? Mark this to 0. We can move in the 4 directions, top, left, down, right? So we move in the down direction, add d to our string. Now mark this to 0. Now again we can move in the 4 directions, but here for this one we can't move in any of these directions. So we'll backtracking from this. When we are backtracking, what we have to do? We have to simply add another character. Let's suppose b, right? So b is indicating what? We are backtracking from this function, right? When we call DFS on this one, we are backtracking from this. Next, here we can move in the right direction. So r is added to here, DFS is called on this one. Now this is marked to 0, means this is visited. Now here we can't move in any of the directions, so we are backtracking. So when we are backtracking, add b to the string, right? Again here from this one also we are backtracking, so add a b to our string. So now our path or the structure of this island is xdb rbb. So add this to the set, that is xdb rbb, right? Now let's check for this matrix. Again new string is there. We are calling DFS on this one, so add x to this string. Now we can move in the in four directions. Top can't move, in left we can't move, down we can move, so add D to the string. Right, now here also we can move in the four direction, but we can only move in the right direction, so add R to the string. Mark this to 0 0 also, right? Mark this to 0. Here we can't move in any of the directions because all the directions are visited now, right? So we simply backtrack. When we are backtracking, add B to the string. Again we are backtracking, add B to the string, and again we are backtracking, add B to the string. So now the structure of this path is X D R B B B. Now these two are different, so the set size of our set is 2, which is correct, right? So what we have to do, we have to apply the DFS function of on all the ones present in the matrix, and each one we can move in the four directions, that is top, left, down and right. When we are moving in the top direction, add T to our string. For left, add L. For D right, add R. For right, add for D add D, and for right add R. Okay, right? So this will be our string. Now in order to find the distinct islands, we have to add this path to the this structure to a set, because the set always contain the unique elements, right? So this our answer will be what? The size of this set, right? So let's move to the code part. Firstly, we are doing what? We are traversing on the entire matrix, the entire array. So let's start the traversal. Now we are applying the DFS on all the ones, right? So we'll check if one is present. If one is present, then we'll call DFS on that one, right? So DFS, we have to pass these matrix, the row and the column, right? Before calling the DFS, what we are doing, we are taking a new string and adding X to that string, right? So here the string is taken as a global variable, because if we take it as a local variable, then every time we call the function it will change, right? So add, take a new string and add X to that string before calling the DFS, right? Now let's create the DFS function, which is of void type. We are taking the vector, the row and the column, right? So we can do what? Firstly we have to mark this one as 0, then we can move in the four directions, right? So firstly mark this 1 to 0. Mark this as 0. Now we can make four calls from this: top, left, down and right. When we move in the top direction, we are decrementing the row, right? So but before moving to top direction, we have to check is this move is valid or not. So when we move in the top direction, we are decrementing the row by 1. So we have to check if this value is should be greater than or equal to 0, right? If and 1 should be present at that value, right? The move which we are going to take, 1 should be present there, then we call DFS on that one, right? So call DFS there on that one, right? But before calling the DFS, what we have to add to our string, since we are taking a move in the top direction, so add a T here, right? Next we can take move in the left direction. When we move in the left direction, we are decrementing the column. So again we have to check if our move is valid or not. It should be greater than or equal to 0 and 1 should be present there. Since we are moving the left direction, so add a character L there, right? This string is going to tell us the path of our island, which means the structure of our island, right? So call DFS. Here we have to pass the area also, right? Next we can move in the downward direction. In the downward direction we are increasing the row, right? So here we are increasing the row. Again we have to check that is this move is valid or not. Are we are moving outside our array, right? So it should be less than the number of rows present in our matrix, right? And 1 should be present there. This is a down movement, so add D. Here it is row -1, right? Next we can move in the right. In the right we are doing what? We are incrementing the column. Again we have to check is this move is valid or not. That is, it should be less than the number of columns present in our matrix, right? And 1 should be present there. We are moving right, so add R here and make this move, right? Next, when we backtrack from this, we are doing what? We are adding a B to our string, right? So when this one completes all its calls in all the 4 directions, this is backtracking from this. We are backtracking from this and we are adding a B to our string. So let's add B to our string, right? Next, what we are doing? We are adding this string to a set, right? So we have to take a set here. Set of string. Right, this is string type, so a set of string. Let's name this set as answer. After coming back, we are adding the string to our set, right? String is what? Path so far, right? Next, after traversing the entire matrix, our answer is stored in what? The size of the set, right? So we have to return what? Return size of set, right? So this is our code. Let's try to run it. We are getting a error, missing template arguments. Let's check this error. Here the name of our set is answer. We are taking the name of our set is answer, so here we have to return answer dot size, this size of our set, right? So successful, which means that our code is correct. Let's try to submit it. So our code is passing all the 5 test cases, right? So we are doing just what? We are traversing in this entire matrix, right? And we are calling the DFS on all the ones, right? We are traversing on this entire matrix. We are calling DFS in all the ones. Before calling DFS, we are taking a new string and add X to that string, right? Next, we are marking these ones as 0, which are visited now, right? Here we can move in all the 4 directions. So we are taking 4 calls here in top direction, in left direction, in downward direction, and in right direction. Here we are checking the condition that if our move is valid, if we are moving in top direction, are we moving outside our matrix, right? So we are checking the conditions and we have to check if 1 is present there. Now if the 1 is present there, then add call DFS on that one also, right? So before calling the DFS, add this to our string. Now this string will tell us the path of our island, that is the structure of our island, right? So for backtracking, we are adding a b to our path, right? So we are getting the unique elements, unique islands in our matrix, right? So this is the question. I hope the question is clear to you. So don't forget to like the video. Thank you for watching.